What is 5G? Well, 5G is the fifth generation of cellular network technology today. 2G allowed us to text for the very first time, 3G brought us online, and 4G delivers the internet speeds that we very much enjoy today. "5G is made out of multiple technologies. These vital technologies are the millimeter waves, small cell networks, massive MIMO, beamforming, and full duplex, which when implemented together allows for 5G to communicate at a throughput that is 10 times greater than 4G. Well, theoretically. To understand 5G better, imagine a car on an inclined slope. At the base of the slope, the car acts as 2G. The internet is transferred using packets of data, and with each expansion of cellular network technology, the bandwidth and transferred data capacity are increased exponentially through each generation. To put it simply, as we go through technological advancements with each generation, so does our cellular network capabilities. 5G will be the foundation of virtual reality, autonomous driving, and IoT functionalities, to name a few. This is simply an astounding feat by humanity, as the capabilities of 5G will only expand the possibilities of innovation of IoT devices and inspire smarter technologies. Now, this is a port. Large cranes, huge amount of cargoes in sea containers, and of course, massive cargo ships make up a working and operational port. With the global expansion of trade and commerce, ports have become the essential backbone and arguably the most efficient way in transporting large bulks of goods to all around the world. These shipped goods aforementioned ranges from crates of rubber ducks to sacks of potatoes and even vehicles. Ports all over the world transport goods using massive cargo ships with a lot of cargo on them. When a cargo ship docks at the port, the gantry crane will unload the cargo from the ship to be placed on cargo trucks. Currently, the way ports are operating are not entirely efficient, and with the possibility of human errors only contributing to its inefficiency, 5G may just do the part. A major part of 5G is the capabilities to have small cells. Imagine a grid system and then divide them into 100 pieces. Each of these divided pieces are called small cells. Small cells utilize millimeter waves and are the unique characteristic of 5G, which enables data transfer at throughputs of 1 gigabit per second with a latency of 1 millisecond. The only downside of millimeter waves is that the range of its signal propagation is less than 60 meters. Now, that is almost half of the distance of a 100-meter track, which when applied to the real world is not a long distance. The penetrating power of the signals of millimeter waves are also considerably weak. Therefore, proposing a store and forward transmission with selective repeat to other small cell networks is necessary to ensure real-time data transmission. To prevent congestion control, all the cargo trucks that send data should use TCP Tahoe that enables it to restart when necessary. If by any chance a node in the network were to fail, the trucks will forward the data to another nearby master node on different trucks that will relay the data asynchronously to other trucks until it reaches a small cell network. This process is called VNet, which stands for Vehicular Ad Hoc Network. When the node is not in use and the master node is not in the range of a small cell network, the master node will enter sleep mode to conserve energy. This method is called the store and forward transmission, and it is a viable solution for packet loss. By following the capabilities of 5G, this will enable MIMO, which stands for Multiple Input and Multiple Output. In short, MIMO is basically a practical technique for sending and receiving more than one data signal simultaneously over the same radio channel by exploiting multipath propagation. So in the case of our newly 5G integrated port, Multiple sensors will be placed on the trucks to ensure that data collected from the truck, such as velocity, location, and the cargo that it's carrying, are constantly being exchanged with one another. These sensors are interconnected together with a peer-to-peer architecture to ensure that only one master node is connected to a small cell antenna. Subsequently, a web server client and the rest of the sensors are slave nodes connected to the master node with a peer-to-peer architecture, which ensures a tight security environment. So, if accidents happen within the network, the incidents can be detected by VNet, and by using the Dijkstra algorithm, which is an algorithm for finding the shortest paths between nodes in a graph, the trucks will reroute to the alternate quickest path to avoid any delay in operation. Each cargo that is on the cargo truck will have a unique identifier. With this method, all cargoes in the port will be easily tracked, easily located, and easily identified for the port operators, or suppliers, or customers to identify the exact location of the shipping cargo. Now, imagine a group of small cells in the network is connected to a client-server baseband station that will transmit the received data to the port operator. By adopting this peer-to-peer architecture for the trucks and sensors, the scalability of the port will be self-scalable. So, to conclude, with small cells used for detecting the location of the trucks, and massive MIMO used for the trucks to communicate and avoid from crashing into one another, the capabilities to produce a real-time map of the port's surroundings will increase the efficiency of all port operations. Besides that, the control room will be able to simultaneously manage different segments of the port logically, ensuring safety and efficiency to the ports. Thank you for listening.